This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome back to the Ship It Show. I am your host, Justin Garrison, and as always is my co-host, Autumn Nash. How's it going, Autumn?
Hey, how are you?
Doing just fine. This show is all about what happens when code turns into software, or what happens after you push Git or hit Git commits. Anything that happens after you wrote that code and now it's someone else's problem. And in today's show, we are going to talk to Wanny and Deepak from Kong HQ, which is a very fancy load balancer, gateway, all sorts of network traffic. But what was really interesting to me was the fact that they run hybrid infrastructure for their own infrastructure on managing Kong. They run it in the cloud. They also run things on-prem, and then they have to provide it as a product that other people as customers can run in a cloud environment and on-prem. And so they have to test it and validate it. And so a lot of that was interesting when we were talking early on. And so that's the interview for today's show. But as always, we want to start with a couple links that Autumn and I found interesting or cool, or maybe even horrible and disturbing. I don't know. One of these weeks, we're going to have something that's bad. But for now, it's still going to be good stuff, right?
Let's hope it stays on the good.
Yeah, we keep it positive mostly. This isn't for news, but this is just something that's, we both were reading and thoughts that you all in the audience would also might find interesting. And so mine is going to be from cep.dev, and it's Jack's home on the web. I don't know who Jack is or what they've done, but the title of the article is "Almost Every Infrastructure Decision I Endorse or Regrets After 4 Years Running Infrastructure at a Startup." It's a very, very long sentence of a title, but really cool to see just someone going through 4 years of startup infrastructure and everything that they thought was good or bad about their decisions looking back. And that hindsight is such a great tool for other people. And I found this really fascinating just because I've never ran infrastructure for a startup, and now seeing how other people are doing it. Now that I work at a startup, it's different experience than working at a large enterprise. But a lot of the decisions were surprising to me. Things like choosing Kubernetes, where Jack was saying he thought that was a good idea. This was something that he would still endorse for other startups to use and for someone else going forward. Because I always heard from the enterprise side, like, oh, you probably don't want Kubernetes early on. It's going to be too complex. You don't need it. And there's definitely truth to that as well. But at least in this case, he was happy that he went with EKS. And some of the other things that he regretted were things like paying for AWS premium support. It was too expensive for them at that stage, and something they didn't really use very often. Same thing with something like Datadog, where I've used Datadog in enterprises and thought it was fantastic as a tool, but I never had to pay the bill. And so that's probably why I was saying, like, oh, I don't really care how much it costs because it provides value. And for some, smaller startups, people trying to find their business or make money, it's probably not a great idea to throw all of your money at service providers up front. So really good article. There's probably 20 or 30 things in this list of endorse, regrets, no feelings about it. So have a look because I found it really cool.
I thought it was interesting because in the 4 years that he has been, kind of collecting this information, it has been a huge change in infrastructure and infrastructure as code, So if you compared to other 4-year periods, I don't know if they'd be as exciting because I feel like the last 4 years, people got really serious about infrastructure as code. And I just think like in general, software engineers were, or just in like, maybe not everybody, but people spoke more about like the actual writing code and getting code to run. But I think people have talked so much about like infrastructure and making things, how you're getting that code out there, and just building it and like green, blue deployments and that type of deal. So much has changed in the world of infrastructure that the way that products that he's used have grown or been better or been disappointing are really interesting because there's been so much competition and growth, and, products have done really well and some haven't done really well, or, some have been what they expected, or even just, I think something that he had said about Kubernetes, like there was a tool that he was using, and then Kubernetes ended up getting that feature, but he didn't even, at the beginning, he didn't think it would ever get that feature, you know? So I think it's like, it's been such a growth period, and people have learned so many lessons that I think that even if maybe you're not in the market for building infrastructure at a startup, just it's almost like a postmortem. Like, I love reading postmortems because the way you can learn from other people's like struggles. Like, I think that's another reason why I love reading like COEs and just any kind of like learning from other people's struggles. It's almost a postmortem of infrastructure and like the goods and bads and learning from it. So I thought it was just a great article for learning opportunities.
Pointing out the fact that this is looking back 4 years. So basically starting in 2020, and in 2020 was the year of COVID, right? And so like what you were doing in 2020 and what's changed since 2020 is very different than if this was an article written, say, in 2019, looking back to 2015. It probably would have been too early.
So I mean, like, that's a very special 4-year time period, because if you look at COVID and then like this, like COVID, cloud, infrastructure as code, like, you know, like so much has happened in that last 4 years. So like where we started and where we ended up and how people were like using and deploying things. I feel like other 4-year periods would not be as exciting to talk about.
Yeah, or all of them would just say, we regret Jenkins.
Exactly.
And
so I just think
it's like a
that
constant
was
for
like,
10 years.
I think it's a really special time frame, and he did a great job of like kind of summarizing them all, and it's just enough information for you to learn, and maybe you can go down the rabbit hole that we all go through, you know, where you like, oh, I've never heard of this, and then you kind of get into it, but it's just enough information to be concise and be like, I didn't know this existed, or that's really cool and I didn't know about that feature, and then you move to the next thing. It's a long article, but it's not hard to read. He did a very good job of kind of summarizing it.
Yeah, the way he just broke it down. Like, one of the things he points out in here was using Homebrew for company scripts. I thought it was brilliant, because we've had lots of company scripts places I've worked, and it's always been in some Git repo, and you have to, go git clone the scripts and then pull it down and then source it in your path or something like that. But in this case, they're like, well, we just pack it in our own private repository. He doesn't even go into that. But as soon as I read it, I was like, oh, I know how you would do this. And that's really cool, because it automatically goes in your path. You already probably have Brew installed in a lot of, maybe at least not on Windows, but Linux and Macs can have Brew installed, and you can just download those scripts however you want, and they go in your path automatically. And Homebrew update is something that a lot of people are already doing. So really cool to see how they're doing that, and the fact that in this case, in the article, he would endorse other companies using Homebrew for scripts too.
Not just that, but like there's only so much you can learn at school. There's so much you can learn in different ways, and a lot of being a software engineer or working in like technical fields are just really on the job. And I feel like articles like this and postmortems are just like such a way of learning more. It's just one of those like underrated ways of like absorbing knowledge, you know?
Yeah, for sure. And my link in the outro today is something I learned on the job this past week. And so exactly, like there's things that you learn in formal education, and there's things that you just learn because someone else was doing it. And you're like, oh, this is how it works. Okay, cool. Let's figure out how we can use it.
And just what you were saying, like now you work at a startup, right? And what if you could take that Homebrew thing that you learned and then take that, now use that at your new job, you know?
Yeah. How about you? You got a link for this week?
So my link is about Reddit. So I've been a long time Reddit user. I don't know about you. Do you use Reddit?
Not very much. I don't know why. I was a big Dig user back in the day, and then Dig kind of exploded, and I never went over to Reddit as much. I use it occasionally, but it's not the place I hang out.
So I love like reading about other people's like views of like a book that I'm reading or like a chapter, and I'm like, can anybody believe that this just happened? And then I like watch a bunch of other nerds like, have opinions and like have a moment about it, and it's awesome because then like you can't talk to your friends about all this stuff because they're probably like being annoyed that you've obsessed over this much detail, So like I love Reddit, and it was kind of crazy to me that they were going to IPO after such a long time of not IPOing, and I was wondering kind of like how that would have like effects on this, like it's a big social media, but it's kind of like not like it, like Facebook got big and new, and then it kind of people stopped using it. MySpace got big before, Facebook, but like they get big and new and everyone loves it, and then people hate it forever. And like Reddit's kind of like one of the big ones, but it's like, I wouldn't say like underground, but like it's not as popular as the other ones, like some people either really
just the structure of Reddit was so different than the other things, right? Because it was the first sort of interest-based social media, right? Yes. It wasn't your actual social network. It wasn't people that you knew in person. It was like, hey,
which is why I love it.
Yeah, if you want to go deep on, I don't know, like hair trimmers or something like that, like there is a Reddit subforum that you can go and
You can do like on smoking meat, like recipes,
Yeah.
like how to clean things, plants. Like it's like, you know, when you go down a rabbit hole when you're like a nerd about technology or about something you really like, and that is what happens on Reddit. Like people will give you like every answer, every like plot twist or how they thought an ending could happen. And it's like awesome because you're all geeking out on something that you really, really like. And if you probably talked to half people you knew that much about something you really like, they'd be like, shut up. You know? So it's like, that's why I love it. Cause it's like a one place that you don't have to tell your grandma and all your friends about like every like interest you have because you can just put it on Reddit instead of Facebook or Instagram, you know?
But so what's the article you had for about Reddit?
Reddit signs an AI content licensing deal ahead of IPO. So I was kind of wondering, like, Reddit's been around for a long time, and they're just deciding to IPO. And I was wondering how this would change the context of like how Reddit operated, you know? And it's like interesting because I wonder if they would have made this deal if they weren't IPOing, because it's a $60 million deal with what they're saying is one of the biggest AI companies, but they haven't actually said what company it is. And this is now Reddit's advised IPO evaluation. They were advised to seek $5 billion. So that's obviously a very different evaluation than they may have gave Reddit not too long ago. But also, like, how does this make people feel that use Reddit? Like, you know, like I felt like Reddit was almost like a safer place away from like, you know, after the whole Cambridge Analytics thing with Facebook. And I think Facebook got really like dark for a while, you know, and like it's interesting to think like, how will this change Reddit? Like, and what kind of data are you getting differently from Reddit that you get from other social media platforms? Because like we said, it's a very different social media platform, right?
Well, and it's always had a lot of the most curated, human curated content, right? It
Yes.
feels like Reddit is still one of the last safe havens for humans to explain their theories in depth on research and various things. I've seen so many like cool, you know, Google Sheets linked in like comments to like, hey, what's the best taco truck in LA? And I'm like, this is fascinating to me. Like, let's go. And someone's like, here, I tried 50 of them. Here's all my links and ratings. I'm like, that's amazing. And I know Reddit went through like API changes and there was a lot of backlash with some of the communities and subreddits. But I'm really curious too how this affects the infrastructure in the software, right? Because as soon as you're like, is this just open to like for a single company to crawl their information? Is this going to be something that they're going to be doing the AI infrastructure and crawling on that? And so that stuff is really cool because I mean, for a lot of people, I know Reddit is the place, the thing you put on the end of your Google search, right? You're like, what's the best toothbrush? Reddit. And you're just going to find the subreddit about electric toothbrushes. And there's going to be some person that has like, here's all the, every Amazon listing. And it's like, that's how people use it now. But if this becomes more ingrained in the product, or if it takes all of that human curation and knowledge, what does that do to the application? What does that do to the infrastructure? That seems really fascinating to me, obviously, because I'm a nerd in that, that regard.
I feel like Reddit subthreads are like, you know, when you and like a bunch of your nerdiest friends get together and the privacy of your own like nerddom and like you have your moment, like, you know, like, but like now it's like, obviously, any free social media, you know that you are the product, right? Like we all know to a certain extent, but it's like almost like pulling back the sheets on the fact that this is where you go to kind of be more of yourself in social media. How does this data change the way that people like are affected by algorithms, you know, like, so it's like, it's interesting. Like, does it make them more accurate? Is it going to start pulling? Like, I remember years and years ago, there was a Target. I wouldn't say it was AI. Well, I guess it is kind of AI, but like they were guessing that people were pregnant before they even knew they were pregnant. Yeah. And I remember that there was this dad and he was like so offended that they thought his teenager was pregnant and she really was pregnant. And it was like how they were going off of people's purchases. So can you imagine with like so much detail of like human curation and like interest, how does this change algorithms? And then how is that used to profit off of, you know? Like in a way it's kind of cool because maybe it helps us define more of our tribe out there or our people, but then also like how will that be like monetized? So it's both interesting.
As a complete aside to what you're just saying, because you were talking about finding your own safe space for your nerddom, you're speaking at the Southern California Linux Expo in March, and I'm going to be there. I help run Kubernetes Community Day and Scale, and I'm excited. We're actually going to be our first time we meet in person. But if you want to come to a nerddom
in real life,
real life,
it's going to be so fun.
And so for anyone listening, if you like infrastructure and software, check out SoCalLinuxExpo.com. Scale is March 14th, I believe, is when it starts, and it goes through the weekend. It's actually like a really family-friendly event, especially for like Saturday. There's a game night.
I think I want to bring my kids next year.
Yeah, my son gave a talk last year, and the game night's really fun. They have a lot of just more family-friendly. It's a community event, and so it's not necessarily like large sponsorships or single technology or company. So yeah, I didn't even realize, like, I haven't mentioned it on the show once, and it's coming up by the time you hear this show.
Hear me out. Next year, we get our kids to like co-write a talk and give it together, and then we'll co-write a talk and give it together. Like, they'll do the kids track, and we'll do like the adult track.
Yeah, that would be cool. So yeah, for anyone that's listening, if you're in or around Pasadena in March and you want to come to a safe space to learn a lot from other nerds, check out the Southern California Linux Expo. And with that, let's go ahead and jump into the interview with Wanny and Deepak and learn all about how they manage their hybrid infrastructure and make a product that other people run in their infrastructure as well.
What you're about to hear are real reactions from PagerDuty users in response to seeing signals from FireHydrant for the first time.
PagerDuty, I don't want to say they're evil, but they're an evil that we've had to maintain. I know all of our engineering teams, as well as myself, are interested in getting this moving the correct direction. As right now, just managing and maintaining our user seats has become problematic.
That's really good. Actually, this is a consistent problem for us and teams. Is that covering these sorts of ad hoc time frames is very difficult. Putting in like overrides and specific days and different new shifts is quite onerous.
Well, and you did the most important piece, which is didn't tie them together, because that's half the problem with PagerDuty, right? Is I get all these alerts and then I get an incident per alert. And generally speaking, when shit goes sideways, you get lots of alerts because lots of things are broken, but you only have one incident.
Yeah, I'm super impressed with that, because being able to assign to different teams is an issue for us, because like the one alert fires for one team and then it seems like to have to bounce around, and it never does. Which then means that we have tons of communication issues because like people aren't updated.
No, I mean, to be open and honest, when can we switch?
So you're probably tired of alerting tools that feel more like a headache than a solution, right? Well, Signals from FireHydrant is the alerting and on-call tool designed for humans, not systems. Signals puts teams at the center, giving you the ultimate control over rules, policies, and schedules. No need to configure your services or do wonky workarounds. Ingest data seamlessly from any source using webhooks, and watch as Signals filters out the noise, alerting you only on what matters. Manage tasks like coverage requests and on-call notifications effortlessly within Slack. You can even acknowledge alerts right there. But here's the game changer. Signals natively integrates with FireHydrant's full incident management suite. So as soon as you're alerted, you can seamlessly kick off and manage your entire incident inside a single platform. Learn more or switch today at firehydrant.com/signals. Again, firehydrant.com/signals.
All right, thank you so much, Wanny Morellato and Deepak Mohandas. I hope I said those right. You're both from Kong, and I'm so excited to have you here to talk about how infrastructure runs for Kong, why it's important, and specifically around running hybrid applications or hybrid infrastructure. Wanny, why don't you tell us what you do over at Kong?
Yeah, thank you. I'm Wanny, working as a VP of Engineering here at Kong. Kong is an open source cloud connectivity company. Kong products are designed to sit in front of your API and microservices. They manage the traffic, the end authentication, rate limiting, logging, monitoring, and a lot more. Kong Gateway in specific, it acts as the entry point of your infrastructure. It manages and helps secure your API. Kong Mesh allow you to manage the communication east-west between your different microservices within your distributed application architecture. And both together, they really enable you to better control, get better visibility and scalability across all your different microservices in your infrastructure.
So fancy load balancers, right? I mean, that's like if it was like sparkling load balancers is kind of where we're putting these things in like if we want traffic coming from outside to come in, we can go through here and do that rate limiting stuff. And if we want traffic inside of your network, we just put load balancers everywhere, client side, server side, wherever a load balance might load balance, we're going to load balance it, right?
Exactly. That is what we do.
And Deepak, how about you?
So my name is Deepak. I work on the SRE team that powers the Kong's cloud platform. So we call it Connect. So that's the platform that powers the control planes of all these gateways. So my team is responsible for building the entire platforms and then build these IACs and GitOps tools for other teams to deploy their softwares automatically, or at least fully self-serviced, rather than us doing all stuff. We build automations for them to do it.
And you said SRE, but that sounds like platform engineering. I mean, that's just like titles are hard.
That's the direction we are pushing. We want to be into a platform and build the automations and self-service model, and teams get full flexibility to own and operate their own softwares on top of us.
And so why is a hybrid infrastructure, something that runs in a cloud environment and on-prem, why is that important for your infrastructure and for customers?
Yeah, so that is crucially important because you really want to balance the high performance, low latency that you expect between, your microservices and your API. You don't want to add, as we were saying before, load balancing all over the place and add, hundreds of millisecond latency on your API call. You want those routing paths to be as efficient as they can possibly be. And that means that your gateways, your meshes, your sidecar need to run very close to where the workload is. And sometimes that is in the cloud, sometimes that is on-prem, sometimes that is on the edge. And so Kong data planes need to be able to run everywhere. At the same time, you don't want your central point of view, your managed control plane to run everywhere too. You want that to be centralized into one place that is highly available, that you don't need to worry about. And that is what we really focus to build with Connect. We have built the data plane to be flexible and smart enough to be able to run everywhere. But then we took the complicated part of the infrastructure, that is the control plane, collecting the analytics, collecting the telemetry, the backup, and all of that, and centralize it as a SaaS offering so that you don't need to worry about that. It just work and run for you, and you just cares about defining where your data plane need to be run. And we found that this is super important because it really simplifies the life of your platform SRE. They don't need to run and deploy very complicated infrastructure. They just need to sprinkle Kong data plane where they need to be. And the complicated part where all the HA, the backup, or where all the big data analytics, data crunching, anomaly detection stuff need to happen, can happen outside your infrastructure. And so this hybrid mode of configuration is what we see picking up a lot with our customer and also internally with ourselves.
And the hybrid piece of that, because someone that wants to run Kong, they can run it themselves in their own data center, and then the collection of data and analytics can go up to you. So they're like, I need to deploy this. I can get a VM. I can have a Raspberry Pi. I can have whatever I want locally that just runs this load balancer gateway thing. But then the data gets sent. Or I can run that in my AWS accounts, and I can say, here, everything is isolated in my AWS account, but I still can send out that data. What is your typical deployment model for that load balance? I mean, like I'm used to, Nginx, and I can just go run Nginx anywhere I want. And they don't collect the data. They just, I scrape it or do whatever I want. Why is running a load balancer with that data more important to have that somewhere else?
As you may start simple with a simple Nginx and very static configuration. And that, bring you 0 to 1. But then when you try to do 1 to n, you start getting much more sophisticated in a number of policies and governance and rules that you want your data plane to enforce for you. And so soon, that traditional CI/CD flow where you need to update your Nginx config and restart Nginx to pick up the new role start becoming just either slow because, your CI/CD may need to deploy and update the config of hundreds or thousands of different Nginx around your different deployment, And at the same time, sometimes you really want a much more central governance. Like you don't want to just review what your different environment in GitHub looks like. You just want to know exactly what happened millisecond ago. And so from that point of view, you want to decouple a little bit the two. You want to have a data plane that is optimized to run in all the different type of infrastructure that you need. Like with Kong, we're building, Deepak was saying about that. We built a Kong operator that is fully optimized for Kubernetes. So if you have the flexibility to run Kubernetes on your infra, either through, one of the cloud provider manage EKS, AKS, or whatnot, or if you run it on-prem yourself, we have a optimized deployment for that. You install the Kong operator, and then we take it from there. If you run it on OpenShift, we have a different solution for that. If you run it on bare metal VM, you can just run Kong there. But all of them, what they do is when wake up, they actually will look for the control plane and for instruction to what to do next. And so you can actually centrally manage your policies and your rules and your services and your URL paths and all what you have to do centrally in one place. And then all these data planes become very stateless. They become very ephemeral. You can treat them much more like cattle. When they get sick, you shoot them, a new one will come up, will connect, understand, get the configuration of what it has to do, and be up and running. And this really makes much simpler to think about all these, load balancer around your service. You don't need to count them anymore. They just, do the right things.
Let's move away from the product and sales pitch here into your infrastructure. How is your infrastructure run in a hybrid way? What are you using to manage it and to roll it out? So is this like hey, we have Terraform for the AWS stuff and Bash scripts for on-prem? Or how does that work?
Yeah, so we do kind of a little bit the same of what our customer does. So, we run a lot of the things in AWS. We deploy EKS and we run the Kong operator for Kubernetes. We actually have another environment that is still in AWS, but there we run our Kong more traditional hybrid mode deployment because that fit best that type of environment. We have other environment that run more traditional VM setup in Ethernet and whatnot. And there we just run Kong on a VM. And for that case, we use Terraform and we install Terraform around that. In the cases where we have Kubernetes, we use Terraform actually to get Kubernetes up and running. And then we actually install the Kong operator into Kubernetes.
How does that handoff work? Because that's a typical pain point for some people where it's like, hey, we have Terraform and at some point you need to break we're either going to use Terraform for the Kubernetes resources, which isn't always the smoothest thing, or we're going to switch over to GitOps, or we're going to do a Helm file, or we're going to do something else once Kubernetes API is available. How do you bootstrap that into an environment to make sure that we need to run this too?
So the way we tried to build was the Terraform was supposed to be provisioning the foundational layer. So in our case, it's EKS, the most foundational one that you get it. And then what we want is foundational layer installs the full CD system. In our case, it's Argo CD. So the Argo gives the beauty of a lot of engineers who wants to have a UI to understand what's happening in the cluster. And it has a lot of functionalities. From our side, what we gave them is there's a GitOps approach where they can define Argo applications as code. So Argo apps says nothing but you define your own deployments. You define your own deployment strategies and how do you want to deploy, because we span across different geolocations. So we have services running in US, Europe, and Australia. Now we want to give the teams the flexibility, you decide how do you want to deploy them. Naturally, we have developer environment, we start from there, but we don't push to all the geolocations. We have a rolling fashion. So we give that GitOps approach where you define your deployment as code for Argo, and then we have GitOps approach. We take the definition, apply the definition, and then let Argo take it from there. And we have a very complex system where deployment start from our least region because we have secondary regions, or let's say Australia is we're pushing on US time. So Australia is the safest time because low traffic. So we start from there. And then once we deploy to that region, we're going to do an integration test, end-to-end test to make sure everything looks good. And then we go to the next region. And this is it's a combination. It's an Argo versus GitHub action. So it's you deploy to one region, and then we have some hooks that triggers GitHub action call and perform another action. So it's kind of a chain workflow, I would say. And then we have different stages where stop and verify that region is completely deployed. It's safe by running these integration tests. If it is kind of having some regression, we break there, page the user or the engineering team so they know, like, okay, should they roll back or should they fix forward? It's up to them.
Well, and you're describing the production side of things, right? This is more or less one environment, but Wanny, you were talking about, you have multiple environments with VMs too that aren't necessarily the same. So it's like, if I am a developer, I want to commit this new feature, and I'm pretty sure I wrote it right, and I have a couple tests, but I need to go through all the stages first of environments, right? So it's like, do I just git push and like automation does all the magic? How does that actually go from I checked in the code to now I'm doing a production rollout? There's a gap in there. If something happens, right?
No. So by default, it's like every engineer who pushes to the main branch, which is the code of their service, what they have, we constantly deploys. There is no like timing or batch deploys. We continuously deploy. That's how we constantly test in dev. And the same pipeline exists there. Whenever they push, we build an image, which is a container image. We deploy to our environment of our choice, which is the dev environment. And there is this integration test constantly running. Now, for production, it's like they decide, they say, okay, I want to put it up. So there's a separate workflow that picks the verified one in dev and then take over and then do the production. But developer is like continuous deployment system that we have.
How long does that process typically take? I mean, even with continuous deployment, if you're going through multiple environments and multiple regions, I mean, that's a multi-day rollout to be safe, right? I mean, this is like, you're just throwing it out like, hey, I can get this out in 10 minutes. Like, oh no, actually, like you have to do, 18 different steps to get there.
Yeah, I think the slowest I've seen is like 40 minutes because of every region, they have integration test suite, and then that kind of test almost all routes what the service does. So basically, like, stress test all the abstractions of that service and make sure there is no regression there. So there's a lot of things that they test in every region and go to even in dev, like I said, there's 2 different geolocations because of we have some global entities and we have some regional entities. So some services has a presence in both. So they have different logic and abstractions based on where they run. So when they push that service, it behaves a little bit different in different. So they have to test end to end to make sure. So the slowest I would say it's like 40 minutes is the worst I've seen.
Yeah. And maybe something that probably we didn't cover is we actually really stress a lot on the automation of this. So when Deepak was describing us rolling the deployment across the different stages, we don't really have a manual check, somebody that goes there and validate. Actually, those automations checks, those validation that prove that the deployment was successful are actually part of the deployment itself. So as the Argo rollout policy happen, and we actually look at the metrics that tell us that service has passed those checks, has passed those smoke tests, and so that get promoted. And this automation itself detecting a deployment going bad and reverting back to the previous no good. And that is what really allow us to not take us a couple of days to do the whole dance, but to be very quick and in a couple of minutes roll out every region. So even when we serialize the different environment, we just, go at 5 minutes at a time, and we end up to at most take, half an hour or so, and not, having manual process in the middle that will force you, for the things to take a couple of days.
And how does that apply when, like, if you said you're using EKS, so you have to upgrade EKS, the base Kubernetes, at least 3 times a year just to stay current. How does that impact your testing and your rollouts and your other things? Because those are sometimes breaking changes or need fundamental infrastructure changes. How does that impact the rest of what the developers are trying to do with pushing out code?
I think the key there is defining the right abstraction. So we are pretty diligent about all the features that we use and not use. For example, our dependency, Kubernetes is one of them, but database are the same. So we try to be, not picking up the chicken sink just for fun, but we try to be very diligent about the list of the dependencies that we know. So then when we actually come to deploying one of these dependencies, we can take EKS, for example, we actually have the list of what we use, and so we can actually go and validate for that. And then, we use the same process. We actually go from the earlier environment to the later environment in that cadence. And sometimes those actually take much longer, especially when we know that there is a breaking change, that we work with the product team, that they actually something the application need to change to move from a version of the secret operator to another, for example. that is where, manual review is actually happening, so that we stage that in a more like slow fashion between the environment to give the team to update, pick up those dependencies and stuff like that. But I think the key, at least from my point of view, is really tracking the feature and functionality that you're using your dependency. So you don't get surprised when you update, but you can actually review what changed and what not, and you can actually plan that upgrade to be successful.
How does it apply for customers though? Because you're shipping something that someone else is going to run in their environment too. And you're running a very specific version of Kubernetes on EKS, and someone else has a GKE version or an old on-prem self-deployed version. And those aren't going to line up with what versions of like that matrix of what does Kong support and what Kubernetes and what VMs and what operating systems we support is not something you can simply just say like, oh, just look at my dependencies. Like that is too complex for any to know ahead of time. How do you deal with that sort of shipping code to a customer?
Let's start probably from the simple use case. For example, you run Kong on a VM. The list of instruction and dependencies that you have when you run on the VM, they're very clear. And so, when you do your yum install Kong or apt-get install Kong, that is actually what guides you through. When you actually go in Kubernetes, that is where, for example, if you look, we used to have like an Helm chart to install Kong Kubernetes, and that hit a lot of the challenges that you are describing. And that was one of the reasons why we actually start thinking about building a Kubernetes operator that we call the KGO. That to really, give you a little bit of a better abstraction and, not having to rely on something that, change often and have that explosion of, test metrics. Instead, taking ownership and get the Kong operator to actually have a minimal footprint of dependencies and build the stuff on top of that. And so that makes you much more resilient about, version changes and stuff like that. Still, there is some times where, if you have migrate from this version of Kubernetes to that, then you need to actually use the next version of the Kubernetes operator and stuff like that. And that still require human communication. We didn't find like the silver bullet to fix that. That is still complicated sometimes and it still require review. But yeah, I think the key there is Kong has done a pretty good job to keep the list of the sub-dependencies to a minimum. So, and those we always pick something that is pretty stable. And so that gives you the kind of like easy of mind most of the time.
In your Kong is a ingress and load balancer inside of Kubernetes, like Kubernetes just went through a whole change of ingress and gateway, like APIs changing. And that was a big change for a lot of people where ingress was never stable, but you were building on ingress and it's not, like as a beta API and customers were using it across the board. And now gateway's there and people have or have not moved to it. And they have a lot of dependencies and kind of understanding around how that works and why they were using it for an Nginx ingress or something like that. Like that is a very different problem where you have a dependency on a beta API that people have been using for a long time that no longer is going to be upgraded. That's a big change. Like that's a big software, like you have to test both sides of it because you're going to have customers on both sides. Like that's not stable at all.
Maybe let me open a parenthesis. Like we have a lot of customers that actually never even wanted to uptake those API and then be running Kong in Kubernetes, not as an ingress, but as another service and using Kong to route the internal services. I see some customers that are just not willing to run on the bleeding edge and they will just not uptake those API. And for those who folks have been running as Kong as another service and use Kong to route the service inside, outside the quote unquote Kubernetes ingress abstraction. I see that a lot. But, we see also a lot of people that like the Kubernetes integration with the ingress CRDs and that abstraction. But with that comes a little bit of, you are on the cutting edge and you need to have, the expertise and the resources to deal with those breaking changes. I mean, Deepak has been to some of our internal upgrade. Maybe you can talk to that and see the challenge that we face ourselves as this stuff was breaking and we were figuring that out.
Yeah, Deepak, I feel like there has to be some very interesting stories as Kubernetes has changed drastically, but even not just Kubernetes, right? Like customers' requirements and expectations have changed. How has that impacted the infrastructure that you're running for like, hey, like when you expanded to 3 regions, like you made that decision and you had to add those extra hooks in that workflow to make sure that you can deploy and make sure they happen in order, and all that stuff depends on where your customers are and how they're trying to use this as a product.
We give the same feedback. Like even for us, when we run our own infrastructure, like we're an open source friendly company. We have a lot of open source softwares that we use. And like you said, like, the upgrades are very critical. So we do like every quarterly check to make sure, like, is there like versions that we need to upgrade for these specific ones? And there are breaking changes, right? So we start with the change logs. There are teams that still have these kind of, like you exactly said, like, we were doing an upgrade like 2 weeks back to 126. And then we found like, there are teams that had very legacy versions, like I think Alpha 1 of HP, the pod autoscaler. So we do that check. We do that check to make sure, like, like what all the APIs that the teams leverage, which is pretty old and deprecated. And then we tend to work with them. So now we go to them and say, we found out this is the problem. We try to work with them. For me, like, we just send PRs to them and say, like, we found this one and it's very stable now in the version. You might have missed it. So, we are helping you there, get it up. And then there are cases where, like, we have to upgrade some critical ones. And that's where the most tricky ones. So now that's where, like, we kind of trust the dev environment. We do like end-to-end tests to make sure, like, some cases it's a breaking one, you have to migrate off. So that requires an old and new one. So you have to have a dual versions of those entities. Let the application shift over to the new ones. Like, for example, the external secret operator. There was the old version, the new versions. There was also a very breaking change that they have to make in the application or the Helm code. So we work with them. We do help them how to zero downtime migrate with them. That's another way we do with them. Yeah, I think the operator was the main thing. And the other one, like you said, like, because Cube, we have to do it like every 3 months or 4 months. Now, there are certain things that we go and help them in the service reviews, like help them to configure like pod disruption budget. So when we recycle the nodes, the data plane nodes on the Cube side, we guarantee you, like, we're not going to cause any sort of issues because these are like customer serving services. So anything that we cause here is going to have a cascade effect to our customers. So we try to educate them, we try to evangelize them the benefits, and we try to, use our learnings and self-apply, which is something we also do with customers also, right? Because in the end, these abstractions are same. Customers also have the same thing. So we dogfood certain things when we do Kong upgrade ourselves and say, we found this one. Now we're sure, like, there are customers who's doing the exact thing, and we give early feedbacks and stuff to teams.
With all the people racing towards hybrid cloud and like infrastructure as code and automation, like more and more like HashiCorp and Terraform are running towards more automation, right? And everyone's trying to build tools to make hybrid cloud more doable and easier to like run. How do you feel like you guys set like yourselves apart from maybe the stuff that like is already out there or that's coming out?
Very good question. I see less as setting ourselves apart and more as playing good into the ecosystem. I think, when you're really trying to deploy something that is not just an hello world, but is, a money-making application, it is coordinating between different vendor and different solutions. There is not just one button that fits all. And so it is about how do you get all these different components to work well with each other. And I think that is where, Deepak was saying, open source come to really help this discussion. How it's very difficult, if everything is closed source, you don't know what anybody else is doing and you cannot forecast it. Being able to see the different components in open source allow you to think through the interaction that can happen and kind of like plan that out and have them to play nicely together. Like one stuff that we see, for example, internally that is working very well is, we do GitOps across the board. And so all our different configurations are in Git. And so what we are start doing for upgrading some of our dependencies, we are kind of like following the dependabot model, tracking your dependency and upgrading with that. And we internally script also upgrade from one version to another or some Helm chart or stuff like that. Like just like last week, we noticed that folks were forgetting to put the timeout, for example, on your GitHub action. And so what we did is we wrote a quote-unquote dependabot automation that went through everybody repo, figure out if you're not following the best convention setting up your job. And we sent to everybody repo APR already with the patch to upgrade that type of GitHub action workflow. And that, I think, it's at least in my experience, what we see internally is a very easy way to remove like the complexity and the interaction between team by just, you have this magic PR that show up and you just review, oh, this is good to me. I'm going to merge it and everything roll out.
How do you build the trust for them to take that PR though? Because also just, giving the trust, the control away to automate things by other people. You know what I mean? Like when you've been running the bash scripts and you've been running your infrastructure a certain way, especially if you've been running on AWS, now you're learning how to run hybrid cloud, or if you've been running with Terraform or Ansible and you've done all this automation and now you're kind of trusting people. I feel like it's hard even in open source where there's a governing body of some sorts, you've got maintainers, or to get people to trust the next upgrade or the next change or the next,
Yeah, 100%. And I think that is probably the key, at least in my opinion. We are not asking the engineering team to give up control and say, you just don't see this part of the infra anymore. You just get this new abstraction. No, we actually send them the PR. They still see what is going. In that PR, there is the link to the documentation of what the change is doing. So that allows them to actually understand the change, approve it, merge it. And that over time build trust because they see that this type of bot is helping them. And so, at the beginning, I remember when I was start using Dependabot, it was like, okay, all this PR, what they're doing. And, you start writing tests, you start trusting them more, you start spending less time to actually, be worried about that breaking up because you have built some tests that will tell you if they break during your CI process and stuff like that. But you still get the visibility into what it is doing. In my previous work, we were working in places where, they changed totally the abstraction. They give you just a black box that you just drop your thing inside and you didn't know anymore. And I feel a lot of pushback from my team in that model because they wanted to know. Even if they wanted to delegate some tasks to somebody else, they still want to know what is going on. And I find this inversion where instead of hiding things from developer, automating things for developer really help to connect that trust and get consistency in automation and get people to keep up with the dependency update kind of work.
I think there's always a worry of if you don't have the context, if it breaks, you can't fix it. I don't know if you can say, but what is the, average amount of people that will accept your PRs? Is it a high percentage or?
Yeah, nowadays, 90% of the PR get accepted. There is always the snowflake, to be honest. I'm not here saying that, we are in the perfect world that all microservice looks the same. There is always okay, but we cannot accept that because we are relying on this other stuff and we need to do this, pay back this tech debt first. But that also helps you to track it. Once you have the PR, we have a couple of scripts in GitHub, so I can actually centrally track all the services that already accepted, the one that are not. And then for the one that are not, we ask the reason why, and we build a plan to build that path to convergence.
That's interesting.
I feel like there's a fine line here for when you mentioned the Dependabot model as being a good thing is not my general experience, right? Because it's it's just sending me more work to do at some level of just you know what? I don't have time to focus on that thing because I have something else to do. And the more automation, the more work you're putting on someone. And in a lot of ways, best practices is very expensive, as we're talking about already, right? Timeouts and pod disruption budgets and all these things are you don't have to worry about them originally because you're I'm just getting started. And then you mature a little more and you're oh, I'm going to get used to doing these things and I'm going to get a little bit better at them. And I'm teaching my kids how to do things and they're not doing it right the first time, but that's okay because they're still trying and they're still putting in effort. And then later I'm going to correct them a little bit. But at some point here, especially with infrastructure, and infrastructure has such a large impact on an organization, downtime, companies can go out of business with major outages, right? This is a very critical piece that you can't just automate everything because you're going to affect someone up the stream that you don't know what they're using or why, or even a customer of oh, I didn't know you had that API. That's crazy. This is a surprise to me, right? This is amazing. But that automation fine line of how much is too much, how much are we actually going to put on developers to say just accept these because 90% of people do, or 9 out of 10 developers accept our PR. So you should too, right? It's the sales pitch of buying a toothbrush or something, right? It's just hey, you should just do it because everyone else did. And no one, at some point you get numb to the automation of I'm not learning anything from this. does. It's not actually helping me get maturity out of it. It's just noise to be able to say, yeah, sure, whatever. Like, I'm not the one to fix it either, right? Because at the SRE side of it, I don't know if developers are getting paid for that, or if the SRE team fixes and debugs everything because they watch Git a lot closer to what a developer might be doing at like a global scale. How does that problem show itself inside of a company that is building something for other people that are also trying to automate on top of you, and as a product that has a hosted service that needs to be up and available? Because I'm sure your availability needs to be higher than your customers.
Yeah, I think you need to go back to the concept of design for failure. To be honest, designing for failure is not cheap and it's not simple and takes time. At the same time, when you work on the infrastructure level or a Kong as a load balancer, that is a must-have. There is no way around that. It takes time to train the people, for people to get familiar, to design and think from failure, from the way you design, the way you test, the way you do your performance test, stress test, the way your CI/CD pipeline is set up. It's yes, we have a lot of new ideas and new projects that start and don't do this from day one because they're proving up a concept, they're proving up a market or an idea or whatnot. But when you start shipping this as production grade software, then that level of maturity, it is, I would say, non-negotiable. And so you need to embrace this responsibility. I would say that is probably my message for people that build this type of software. Like, that is what your user expect. The stuff have to work. It have to be able to cope with a certain amount of failures. You need to be able to gracefully degrade when those happen. And you need to think about this. And this is extra work. But it's kind of like unavoidable when you build this type of software. Like, if you build a load balancer that doesn't have good uptime or a good failure mode, it may be the best one you ever built. People will run it for a couple of hours. It will fail on them. They're going to revert back and move on to the next one.
I'm pulling out what you just said about this type of software, right? Because that failure mode is very different depending on what you're building. I took down my personal website last night and no one said a thing, right? Like, I was messing with it and I broke it. I'm like, it's fine. Like, it'll come back up and it's mine. I'm not making money off it. Even the people that might come, they're like, maybe they'll come back tomorrow. I don't care. There's nothing here. There's no responsibility here. But on like running like Disney Plus, like our front end was just a few Nginx boxes, and they're like, the failure modes of that was like auto scaling groups are fine. Like, we didn't need Kubernetes at the edge. We didn't need a lot of it. Was like, hey, you know what? Like, a few Nginx boxes handles the load, a load balancer in front of that, and we're good. The failure modes are very different for different people and what they are doing, right? If someone can't load Moana, that's okay. Like, they're going to hit play again, and we'll probably pick them up next time, and a new box is going to come. So like, failure, even if it's not an option as you're building this for customers, there is a vast array spread of what failure means for different people and how much tolerance they have for, like, can that be down for 10% of my hits? Can that be down for 5 minutes? And that all is like very negotiable when you're talking to a customer.
It's also amazing because it's different industries, like retail. People have gotten to the point of they're so used to having instant gratification that, like, I think if you take 2 seconds more to load, people will go to a different website and spend money there. It really depends on the industry you're talking about, because it's amazing the amount of like demand that people want when it comes to buying something.
Yeah, that's interesting with Kong, right? We have all these kind of different industry, right? Because we powers the APIs, and it could be healthcare, it could be entertainment. And they have, like you said, there are different failure scenarios. Like, some can take that hit. Some are very sensitive in finance, banking, for example. Like, you're doing like a transaction, which is like a sub-millisecond. Sometimes your one-time failure, okay, like if you have consistent failure, that is a very bad user experience, right?
Yeah. You need to understand the space where you're in, what you're okay with and what you're not okay with. So there you can make the right decision. And, you can decide, if we go back to what we were saying before, if you want to dedicate a sprint to update your dependencies, or if you want to do it during your currently daily work. It depends on what you're doing. And I think we need to trust and empower the engineers that are responsible for that service to make that decision. I don't think there is some top guidance that apply for everybody. It's giving them the tool, giving them the knowledge, giving them the automation, and they will have the context to make the best decision. And that feedback loop to keep making things better and improving and learning always exists. by the end, the responsibility need to land there.
Yeah, from infra point of view, right? So the common thing pattern, at least I've observed, is people tend to copy paste a previous stale config when they create the next one, right? Like it could be a lack of service onboarding or something, but the common pattern is like, oh, there is something already working. I'm building a new microservice. I'm just going to take all these infra abstractions, like Helm chart or something, copy paste here, make some changes, get it up. So you take that baggage and it goes over.
I am absolutely convinced that every company has one Jenkins file and everything was a fork from the one that worked, right? Like someone got the Jenkins file to work and everyone forked it from there. And that's just like, that's how it started. Well, Deepak and Wanny, this has been great. And I think that the best thing that I've learned so far is like maturity can go up, but it does depend on how much maturity you need. You don't have to be the utmost, most mature, we do everything perfect. It's like, actually, that just takes a lot of time and that's really expensive. And you have to figure out for yourself where you're going to spend that time and that budget of like, I can't do this today. And that's okay because I don't need that level of maturity. Maybe I don't need pod disruption budgets. That's fine for your industry or whatever you're doing. So that's really cool. So I want to thank you both again for coming on the show and talking to us about your infrastructure and the process for rolling out code. That's been great. And where can people find either you online or more about Kong?
Yeah, so if you guys just jump on konghq.com, there you find our public site. If you want to hit us on the social media, I'm like Mr. Wanny. Deepak, if you want to leave yours.
Yeah, I'm in LinkedIn. I'm full active on LinkedIn, so it's fine. Yeah.
Thanks so much for coming on the show.
Thank you.
It was nice meeting you both.
Have a great day, guys.
Thanks a lot.
Bye.
This is a changelog news break. GPT Script is a new scripting language to automate your interactions with LLMs, which for now just means OpenAI. From the project's homepage, quote, "The ultimate goal is to create a fully natural language-based programming experience. The syntax of GPT Script is largely natural language, making it very easy to learn and use. Natural language prompts can be mixed with traditional scripts such as Bash and Python or even external HTTP service calls." End quote. The project includes examples of how to plan a vacation, edit a file, or run some SQL. The central concept is that of tools. Each tool performs a series of actions similar to a function, and GPT Script composes the tools to accomplish tasks. You just heard one of our 5 top stories from Monday's Changelog News. Subscribe to the podcast to get all of the week's top stories and pop your email address in at changelog.com/news to also receive our free companion email with even more developer news worth your attention. Once again, that's changelog.com/news.
Okay, thank you so much, Wanny and Deepak. That was awesome just to be able to hear how you're managing your infrastructure and how you're managing your product, because that's something that not a lot of people have insight into because either they aren't doing it now or they don't have to do it. And so, yeah, if you're learning from any of these episodes, feel free to reach out to them online. Both of them, I think, have their LinkedIn profiles here in the show notes. And I'm sure they'd love to hear from you. And if you have other questions, hopefully they're okay with you reaching out and talking to them. If you have questions for us on the show, please email us, shipit@changelog.com. We would love to hear what you are interested in. If there's someone you would like to hear on the show or a topic you're interested in and want to hear us for a future episode, please email us and let us know, because we're always looking for more topics. For now, we're just running with whatever interests us and whoever's reached out. And so the more we hear from you, the better.
What's your dream topic, Justin?
Ooh, dream topic. That's a hard one. I love hardware and data centers, and I actually think I want to talk to someone.
You to reach higher, like dream. Like, what would you like nerd out?
I mean, I guess at that point, it's probably like some like special guests to have on the show. I want to talk to like, I don't know, some of the first creators of Tim Berners-Lee or, ARPANET creators, or like that stuff's like super cool to me. I love the history of it all.
We should do a history episode.
We should do like, how did this come about? Would be really fun.
That would be cool. Or how is this made?
Oh man, that show. How's it made?
I love that
Now
show.
I'm gonna go down a rabbit hole.
I love that show. You have 14-hour plane ride.
I have a 14-hour play run there and back. I'm going on vacation, but I bring like a month's worth of movies. Like, I'm never gonna.
You gotta have choices.
Yeah, I know, right? It's like whatever I feel like at the time. Like I don't know why.
I always go with way more choices than I actually use.
Yeah, I'm gonna bring like 8 new things, and I'm gonna watch something I've already seen like 20 times. So for the end of today's show, we want to talk about something that we learned this week. I dubbed this session "This Week I Learned" or TWIL. I'm just making up acronyms now. Everything gets an acronym.
Look, I need you to like make your like Justin acronyms for like every like end of show thing.
Most of them have something. Yeah, we have some way to pronounce it wrong.
What was the first one? Because that like made my whole life.
That show never shipped. It was what.
We're bringing that back, like
WTA. No, we'll get that episode in soon, or at least that's outro in at some point. But yeah, we had a what the acronym. So this week is TWIL. This week I learned, and for me this week I learned all about conventional commits. If you go to conventionalcommits.org, it's a way to have your code committed in a way that's kind of human friendly. And I have always stuck with kind of an old school way of committing messages. I mean, there's always the fun messages of like, will it work this time? Please Jenkins, don't fail, all that sort of stuff, and plenty of swear words. But in this case, conventional commits are all about making it a little more scannable for humans to be able to see like what your commit's actually about. And so you have things like a fix or feature or docs or refactor are all like headings on it. And then you can also put things like exclamation points in the title of your commit message to know like, oh, this is a breaking change. So you can say like, oh, this is when we broke something. And then you still have some of those like, sentence structure about what you changed, but it's a much more scannable way of doing it. And they do this at my new job at Sidera Labs, and then also with Project Bluefin, which is a Linux distro that I'm part of. And so I was committing to the main repos on both those this past week. And in both cases, I realized they were doing this, and I didn't even know what it was called. And so thankfully in the uBlue or the Bluefin contributor guide, they said, oh, use conventional commits. I'm like, oh, I did not know this was actually like a formalized thing. And so there is a spec for it. And it's not, a hard rule of like, you have to do it this way, but it's like, hey, we would like you to adhere to this as much as possible so that it's easy for us to maintain long-term. So I found it fascinating and I wanted to share it in case anyone else didn't know about it and wanted to start using it.
That's really cool.
What do you got this week?
So I don't know if it's new, but I was reading about threat modeling and I really like OWASP for like just learning about stuff. And they actually have a whole GitHub repository about, it's called the Threat Model Cookbook. And there's just so much to learn, I guess. I really geek out about security and just like learning new things. And I really like reading postmortems, of course, but it's just really cool that not only is this something that is contributed by multiple people, but there's all these different examples of different like threat models and how you can publish them and how you can kind of learn. So it can be in a form of code, graphics, or text. And there are all these different like tools and methodologies and technologies, and it's a really cool place to start, if you're like getting into threat modeling and you want to learn more about it, because I think the more we educate people about security and kind of make it digestible and something that people can like on their own learn and get information about, it becomes something that everybody becomes passionate in, and it's easier to get people on board when you want to make serious changes, so I think I thought that was really cool that people put in the work to really build this repo and put in all this information. And it's a cool place because people can contribute more information, and kind of like their ways of doing it. And the fact that there's all these different mediums of threat modeling. And not only can people go and learn and contribute, but I just hope that helps people to get more passionate about security in general.
And speaking of acronyms, because we were just talking about that, OWASP stands for Open Worldwide Application Security Project. So you can find it at OWASP.org. It's a neat foundation that's or group that has these sorts of guidelines for people that are like, hey, how does security work like at a larger scale than my one application or my piece of infrastructure? Like we need to be able to do this like more broadly across companies, individual companies, and also like open source projects and everything else.
Honestly, they are just such a valuable resource. There's so much you can learn from just their main website and so many products they've been involved in. I took security classes where they almost like verbatim took OWASP like text. They were like, we're not even going to do a textbook this week. Just go read their website. Like, that's how good it is. Like,
Yeah.
There's so much just valuable information. And I think when it's stuff that we need, I think security is a need. It's not a want. And I think the fact that people make it like freely accessible to learn about it is just really cool. And it's an organization that's like, a nonprofit where people are contributing their time and effort to push security forward and make it better. And I just think it's a really cool organization, and it's such a valuable resource, and they just do really neat ways to teach people.
Well, that's awesome. So thank you everyone for listening to the show. And again, if you want to have a guest on the show or a topic that you want us to cover, please reach out via email at shipit@changelog.com. And we will see you all, or at least talk to you all next week.
Thanks, Justin.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at fly.io, to the mysterious Breakmaster Cylinder for these dope beats.
Oh yeah, my pleasure.
And to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.